Period 9 today. We have a lot of people here today. We have Judine, excellent student. We had Matthew, who came after school yesterday, but was too frightened to stay. That's okay. Lucas, excellent student. Roman. Justin, representing the great country of the Philippines. Excellent. Now, what I want to do is, I want to do a problem. This is the problem. I want to, can you hear me?
Yeah.
Okay. Thermodynamics at Yankee Stadium. Okay. What mass of steam is required to melt 10 kilograms of ice from negative 50 degrees Celsius to 60 degrees Celsius, and the steam has an initial temperature. Bye, Jackie. You want to stay for this? That was Jackie. That was a cameo visit. She's going to watch us online later. Excellent. And then the steam has an initial temperature of 140. Okay? You got the problem?
Yeah.
Did I do that all right? Okay, now, this is the graph. You want to keep in mind. All right? So let's just know that this is Q1. This is Q2. This is Q3. This is Q4. That's Q5. Can you see that?
Yeah.
Where's the barrel? Dos puntos. Okay. Okay, easy? All right, now. So what I'm going to do is this. I'm going to have the answer sheet in front of me. Okay? Can you see that?
Yeah.
Can you see this? Is that coming up?
Yeah.
Yep.
Right? And then I'm just going to fill it out. And here, bring me that. Can you see am I off the thing?
No, you're good.
And this is going to be this graph, right? And this graph, right? Easy?
Yep.
So it's actually, it's not a bad problem altogether. It's pretty straightforward. We've been doing it for a while. All right, so the first thing I want to do is I want to just start with the equation that we're using, okay? That's a good place to start, don't you think? Okay, and I'm just going to write on the board. I'm going to do the whole board one take. Got it? And I'll just erase it instead of stopping, starting, okay? You ready? Okay. I know that's true, correct? And I know that this is therefore true. Correct? Heat gained equals the additive inverse of heat lost. Okay, you with me? Okay? All right, now. So let's start off with heat gained. Okay? Let's start off with heat gained. All right? All right, now. Heat gained is going to be the ice. It's right here. So it's going to be the mass of the ice, right? Times the change in temperature of the ice, times the specific heat capacity of the ice, correct? So, I'm going to go way over here, and I'm going to say heat gained equals, and I'm going to use I for ice and S for steam. Is that okay?
Yes.
I for ice and S for steam. Yes?
Mm-hmm.
S for solid. No, never mind. Okay, is that fine?
Yeah.
Okay, all right. So, W for water, for liquid water. Is that good? You all right with that? Okay. So, the mass of the ice times TF minus TI times the specific heat capacity of the ice. That I is initial. That's not ice, right? That's the initial, right? TI. That I, right? and then I'm going to add to that, this is Q1, then Q2 is going to be the mass of the ice times heat of fusion, right? That's Q2, correct? And then this is going to be the mass of the ice, and now we're in Q3, so it's going from like 0 degrees is the initial to 60 degrees. So it'll be TF minus TI and specific heat capacity for water. Okay? You all right with that? And that's Q3. Are we cool? Yes? You all right with that? Okay? They're all stunned. Silence. It's unbelievable. All right, so let's just plug in, okay? Can we plug in? First of all, remember, Q1, Q2, Q3. So we're going to like right about there, which is like 60-ish, right? So here, we do this one first. So it's going to be
-50.
-50 is there, so it'll be 0 minus the -50. There's no temperature change there. There'll be 60 minus 0, right?
Yeah.
60 final minus 0, okay? Yes? All right, so mass is 10. All right, so 10 times 50 times
0.492.
0.492. This is going to be 10 times 80. I'm leaving off the unit labels. Okay, my apologies. My apologies to the purists out there. Okay, that'll be 10 times what? 60 minus 0 is 60. Right? So what is, help me out here, okay? What is 500 times 0.492? 500 times 0.492. 246.
246.
Even? Ja? Okay. 246. Right? And we know that that's what?
Q1.
We know that's Q1 and it's positive.
Yeah.
Right? So go to your sheet and fill in Q1. All right? Positive. This is 800, also positive. How do you, without looking at the mathematics, how do you know these numbers are positive?
Because they're gaining.
Because they're
Yeah, because it's endothermic. The ice is gaining heat, right? Okay? And this is going to be 600. So right away, now we know Q gained is 246 plus 800 plus 600. What is that?
1,646.
1,646
kcal.
kilocalories. Yeah, are we there? Okay. Now, can I erase this? Do you want to look at that first for a minute?
Wait, so Q gained is 160?
That's Q gained, yeah. That's what I was doing, right? Look back. Right? You with me? So 1646. Very near the Civil War in the United Kingdom. 1646, 1648. I think 1649 they actually executed King Charles I. Is that right? Can you imagine an American that knows something about the history outside the United States? Isn't that amazing? The world thinks that we only know about... Astonishing. It's a good word. I like that. SAT word, right? Yeah. Excellent. Astonishing. I like that. Yeah, it's a lot of syllables there, big guy.
That's funny.
Be careful. Astonishing. A lot. Okay. So we're going to put up here, we're going to put Q gained as 1646. Okay? Is that all right? And we're going to say that's positive. All right? Yes? Okay. Now, let's do heat lost. All right? Heat lost. The steam is losing heat. It's going to start up here at 140, right? It's going to go, the first transition is Q5, 140 to 100. Q4 is 100 to 100. Heat of vaporization. Q3 is going to be 100 to 60. Negative, negative, negative. Why? Because it's giving up heat. It's exothermic. It's all going to be negative, right? Yes?
Yeah.
All right, now, so let's write it down. All right, you ready? All right. I like to start with Q5 because that's the path it's taking. It's starting with Q5. Yes? All right. All right, so it's going to be M, wait, hold it. It's going to be M steam, TF, TI, right? Yes? Okay. And it's Q5. I didn't put that for Q gained, but I like that. That's the subscript. I'm saying that's Q. That's the change in temperature for Q5, right? And then that's going to be Q5 plus M HV Q4. Again, negative, negative, right? And then what? M steam, right? Times what? T final minus T initial. Right?
Yep.
Is that good? Are we there? We have a question.
For Q5, why don't you put CS at the end?
For Q5,
Because it,
Like you mean the steam, like
yeah.
excellent, excellent. He said, well, what happened to QS, right? For steam, right? The specific heat capacity for steam. Where did it go?
Yeah.
Excellent. Right? You know, all right, back up. Let's have a little bit of a subscript discussion. Subscripts there's no convention really for subscripts. It's whatever's convenient. Oftentimes, I will put S for solid, L for liquid, and G for gas. So I could put C sub S for solid, C sub L for liquid, C sub G for gas. You know, it depends on what we're doing. So when you're talking about subscripts, don't draw conclusions about subscripts and what you think it should be based on your past experience, right? Know what you're doing at that particular moment in time. There's no real convention, subscript convention, all right? So somebody said to me yesterday, oh, they're confused because you're subscripts. Well, you shouldn't be. Don't judge a subscript based on what you or the teacher may have used last year or last week. Understood?
Yeah.
I'm simply saying to you today, for this problem, S is steam, I is ice, except T sub I is initial. That's different. Yes? Okay? That's a good point. I left off specific heat capacity for steam, S sub S. Okay? That's going to be 0.483, correct?
Yes.
Okay. So now, let's do this. Okay? I know that this is going to be negative, negative, negative. Because they're all exothermic, correct? Okay, now, we don't know what MS is. So let me sound mathematical for a second, okay? Listen to my words. Are you ready? We are going to write heat lost, QL, in terms of the mass of steam as the unknown. Okay? All right. this is going to be what? What's that value going to be? 40, right?
Yeah. Yes.
It's going to be negative 40, but we took care of that by saying it's exothermic. You can let the mathematics work with you, or you can assign it. One way or the other, you have to interpret. Okay? So this is going to be 40 times 0.483 is what?
19.32.
19.32. 19.32, and that's negative. Okay? 1932. Yes? Franklin Delano Roosevelt was elected President of the United States for the first time. Okay? Excellent. I love doing math and history. It's wonderful. Okay. Q4 is going to be MS 540, right? It's going to be negative MS 540. Correct?
Yeah.
Yes? And then Q3 is going to be MS times 40, right? 60, right? Yes? 0 minus 60 is minus 60. So it's going to be negative MS 60. Correct?
Yep.
Now, this is what I want you to do. I want you to add up 19.32, 540, 60. I can tell you right away, it's going to be 619.32, correct? Yep. 619.32 MS. Okay? Are we all right with that? Okay? So we're going to say heat gained, heat lost is negative 16,
Negative 16.
I'm dyslexic today.
Let me see that.
619.32 MS. Right? I'm just writing, what did I say I was going to do? I'm writing the heat lost in terms of MS. I'll go and fill in what QL is once we determine the mass. Okay? Yes? Okay. All right. I can erase this? Okay? All right, isn't that what we have? Yes?
Yes.
Yes. Now, magic show time. I'm just going to say, you ready? You ready? Negative and negative. Right? Cool? You like that? Wouldn't it be wonderful to have paper and be able to make those corrections just like on a whiteboard? But it's paper. Something to invent maybe, okay?
That's why you have an eraser.
Yeah, I like that. Okay, now, so divide through. 1646 divided by 619.32. MS equals what?
2.66 kilograms.
2.66 kilograms. Okay, now, multiply that by 2.66. What do you got?
1,647.
Right? Yes, you got it?
Yep.
Now, what you have to do is Yeah, plug the masses in, and we'll do that. We'll do that in a second. But I just want to do this one thing. All right? You ready? I'm going to do a quick exercise with everybody here and here. Okay? I have a lot of people here for a period 9 on a Friday, don't I? I have 6 people. That's a lot. Yeah? Okay? Now, Q1, Q2, Q3, ice and steam, Q4, Q5. Initial temperature, final temperature. That's all I want to do, okay? For your answer sheet, yeah? Okay? Q1. The first temperature I give you will be initial temperature. The second temperature I give you will be final temperature for that heat, okay? Okay. Q1. Negative 50, 0. Q2, 0, 0. Q3, ice, 0, 60. Q5, 140, 100. Q4, 100, 100. Q3, steam, 106, 100, 60. Okay, got it? All right. So I'm going to erase all this. Is that all right? All right. Now you guys took great notes, right?
Yeah.
All right. Now remember when we were doing this? And we put Q5, Q4, and Q3 steam in terms of M, right? Before you added it. What was Q5?
19.32.
1932 MS.
Yes.
Right?
Yeah.
What I'm doing is, I want you to be able to do all of your heats on your answer sheet. Q1, Q2, Q3, ice and steam, Q4, Q5, okay? So, that's going to be, plug in,
2.66.
oh, we didn't put this. Mass steam is what?
2.66 kilograms.
All right, so multiply 19.32 times 2.66 is what?
51.39.
It's going to be negative.
$540 times 2.66.
1,436.
1,436.4.
1,4.
I'm very deaf. Just want you to know that.
1,436.4.
Okay? Yes? One more caveat. Caveat emptor, what does that mean? Caveat emptor? Caveat emptor, what does it mean?
Caveat means warning.
Yeah.
Yeah.
So
What's
Final
emptor?
warning.
Emptor is, the buyer is the emptor. Employee, employer, emptor. Buyer beware, caveat emptor. Okay?
Conceptually understand.
All right, and then Q3,
Was 60.
what was it written in terms of?
60.
60.
60 MS.